A map is a representation of the real world. People use maps to communicate information about the world, such as features on the Earth, to an audience. The features are generalized and displayed using symbols, which represent the features in a way that readers can interpret. Therefore, map symbols are important regardless of the reader, the map media, or the map scale. Qualitative data versus quantitative data. Creating symbols to represent your map data is important because symbols help your readers interpret the map. After you decide the objective and intended audience of your map, you will identify the data that you will visualize. First, you must determine whether you will need qualitative or quantitative data. Either type can be shown with vector, point, line, polygon, or raster symbols. However, each type of data has different rules, classifications, and conventions. Qualitative data explains the category or type of features or phenomena. It cannot be measured. It provides information about the qualities of that category or type. Examples of qualitative data include crop types, corn, wheat, and so on, and zoning categories, commercial, agricultural, and so on. Quantitative data. If you want to show how much of something exists, you will use quantitative data. Quantitative data can be measured. It can show a quantity, a magnitude, or a rate. Examples of quantitative data include temperatures, sales data, and voter turnout rates. Levels of measurement for cartographic data. You can categorize all data, whether qualitative or quantitative, into one of 4 levels of measurement: nominal, ordinal, interval, and ratio. The categories are then used to create symbolization that will show the differences among the features. The nominal and ordinal levels are associated with qualitative data, and the interval and ratio levels are associated with quantitative data. After you categorize your data layer, you will better understand how to symbolize it on your map. Classification methods for quantitative data. Classification of quantitative data means to assign class intervals to numerical distributions. In other words, to simplify the features, you group similar features into classes. Classes help your map reader understand complex groups of features, distill information, and more easily spot patterns in the data. You can classify both raster and vector data. The number of classes and class intervals that you choose will affect the appearance of the information on your map. With different classification methods, you can change the interpretation and meaning that the reader gets from your map. You also must balance the amount of information that you provide to the reader with how easy or difficult it would be for the reader to interpret that information. Common classification methods. There are many standard methods for classifying data. These methods can be based on the distribution of the data, the reader, what you want to highlight in the data, and so on. Here are some common classification methods. Visualized using population density, number of people per square mile. 1. Equal intervals. With equal intervals classification, intervals between class breaks are equal, but the number of observations within each class is unequal. Advantages of equal intervals classification methods. 1. Range of data values are divided into equal-sized subranges. 2. Intuitively meaningful and easy to understand. 3. Good for when data values are equally distributed, roughly same number of low, medium, and high values. 5. Outliers are easy to see. 6. Good for showing differences in the values among areas. 7. Best for familiar data ranges, such as percentages and temperatures. 8. Less ideal when data values are not equally distributed, for example, many more low values than high. 2. Natural breaks, janks. With natural breaks, both the intervals between class breaks and the number of observations in each class are both unequal. Classes follow natural breaks in the data, so there are clear distinctions between classes. Minimizes variation within classes, grouping similar values together, and maximizes variation between classes to show the differences. Good for mapping data values that are not normally distributed. Good for showing the most variation in data values across the map. 3. Quantile. With quantile classification, the intervals between class breaks are unequal, but the number of observations within each class is equal. Equal frequency in the number of observations in each class gives the best portrayal of the data when the range of values for each class is approximately the same. Outliers are not as obvious because they get grouped with other high or low values. Good for ordinal data. Best way to compare maps that have different data ranges. Always compares high values to high values and low values to low values. 4. Standard deviation. With standard deviation, you have equal intervals between class breaks and an unequal number of observations. For normally distributed data, you can use the standard deviations from the mean to derive class breaks. Each class is equal to a fraction or multiple of one standard deviation shows how much the data differs from the average, mean, data value good for normally distributed data, but may require additional clarification or metadata for the map reader.